Hi, I'm Justin Kirk, and in this video I'm going to show you how to make the evil black blob. So before we get started, I'd like to encourage you to like and subscribe to the channel. And basically in my game what it is there's shrines, and your stickman character can walk up to the shrine, and 80% of the time it will give you a power-up, and 20% of the time it will spawn an evil black blob, and you can't kill the black blob. It's invincible, and it follows you between rooms, and it'll just follow you until the end of the run. I'm also gonna make it so that like the light card kills it. It doesn't do it yet right now. It has no way of dying, but eventually I'm gonna make it so that the light card kills it. But yeah, let's get started. Alright, so the first thing we need to do is go into Blender and make ourselves a sphere. Now, we can't use the sphere that comes with Unity because it doesn't have enough geometry, so when you start moving the individual pixels around, what will happen is it will have holes in it. So you could either make a sphere in Blender and give it more geometry, or you could use tessellation if you're using the high definition render pipeline. If you're watching this video, there's a low chance that you even know what tessellation is or how to use it, so let's just do it this way. So you just go into Blender and press tab on the default cube, and you could just right click and press subdivide a bunch of times until it has a lot of geometry. You don't need to subdivide it too many times, but this is probably fine. Then go to mesh, transform to sphere, and then just drag it until it goes into a sphere, and then you could just go file, export, FPX file, change this to FPX unit scale, change this to Z forward, and then export it. So when you're done that, you need to drag it into a folder in Unity, and then in the folder, drag it into your scene, and you should end up with something like this. I've changed my scale to 9 by 9 by 9 because my scale is massive, but yours is probably not massive, so you could probably leave yours at 1 by 1, but I'm going to be using 9 by 9. So I'm just going to right click, and I'm going to unpack this, and then I'm going to right click at the bottom here, and I'm just going to create a material, and we're going to call this blob material. And then I'm going to right click and create a shader graph. It's going to be a lit shader graph, and this is going to be called blob shader. And then in the material at the top, I'm going to change this to the blob shader. And then I'm going to drag the material onto the sphere. Let me just make sure. Yeah, okay, cool. So then if you double click on the shader graph, it will open. Okay, so first things first in the shader, we just need to set up the scale. So that it's going to be the scale that's what moves the points, like out and in. So I already showed in extensive detail how to do this in my video on how to animate a ghost. So what we need to, anytime you use scale, these are always the nodes you're going to use. So you should memorize this because this is really, really useful. So you need the position node, and you set that to object, and you need the normal vector, and you set that to object. And what you do is you take the two of these and you multiply the normal vector by an amount, and you add them together. And when you add them together, you put it into the position node, and then whatever this is multiplied by will be the scale of the object. So let's change this to 1 and 1 and 2 so you can see what I'm even talking about. So if you look at this, if you click on this, you can see that the z-axis, because this is rotated, we should actually have this not rotated. Let's put it to 0 so that we are not confused by it. But you can see that the z-axis is stretched to double the size. So this is how you can change the scale of an object, okay? This isn't the exact way we're going to do it for this shader, but this is how you, anytime you change a scale on an object, this is how you do it. So let's just change this to 1 for now so that we're not getting confused. And we're just going to change a lot of things around here. So the first thing that we need is we need two variables. One is going to be the fluctuation speed, and the other is going to be the speed. So let's go to the blackboard and let's open the graph inspector, and let's create two floats. One's the speed and one is the fluctuation speed. Fluctuation. Okay, cool. And let's just set both of these to 1 for right now. We're going to obviously change these in the inspector, but let's just get out of that. And yeah, so we just need to put the fluctuation speed here, and we'll put this into a multiply node, and we'll put this as the B, and we're just going to minimize this. And then we're going to make a time node. Anytime you want animation in a shader graph, you need to use the time node. So the time is going to get multiplied here, and then we're going to multiply the time again by the speed. So let's do that here. And then speed can go here, and then this is going to go into sine. So if you remember from the other video, sine is a number between -1 and 1, and it just goes back and forth. So instead of counting up indefinitely, like time goes 0, 1, 2, 3, 4, 5, etc., sine goes -1, 1, -1, 1, etc. forever, right? So then this is going to go into a remap node. And remap, what that does is it takes the value that you have and it changes it to the range at the bottom. So instead of it going between -1 and 1, it's going to be going between 1 and 3. So because we don't want the object to have a negative size, even for like the parts that are going inwards, it's not going to have negative. It's only going to be in the positive. So we're like, there's going to be spikes coming out of the ball, but there's nothing going in the ball, I guess. So this is changing it from -1 to 1 to 3. It's just a range change, right? Let me minimize these so this doesn't get too cluttered too fast. Anyway, so then this is gonna go into a remap as well. Now we want these numbers to be the same. So whatever you're doing here, you need to do it here as well. You could make a vector 2 for this. So if you go here, you could make a vector 2 and call it the size difference, and go to the graph inspector, set this to 1 to 3, and then you could drag this here and put this to both of these. That way, if you change this number, it will stay the same. It has to be the same, or else you're going to end up with holes in the geometry. So what we're doing will result in holes if you don't have these numbers being the exact same. So let me just minimize these again or get rid of them. So this top remap node is going to go into the cell density of a Voronoi node, and then we're going to have time go into the angle offset of the same Voronoi node. Okay, so size difference must not be set. Let me just go back here for a second. Oh no, it is set. Okay. So then we need to drag these guys a little bit closer, and so the normal vector is going to get multiplied by the output of the Voronoi. That's not looking right. I'll just minimize it so I can't see it anymore. And we're just going to change this to world space. And let's just minimize all this stuff so it's not so big. So then we want to multiply this remap. So this will go into here, and then this will go into here like this. And then they go into the add node with the object position. Okay, let's see. So we'll put these like this. We'll minimize these down, try to put these together so it's all on one screen so you can try to copy it. All right. So let's save this. Actually, all of it can go closer to the actual node. And let's save this and see what happens. Perfect. So this is exactly what we were looking for. So let's go take a look at this again. So the other thing we need to add is the color. You could just set this to black here, or you could make a color property. That way you can change the color if you want to. You could also do some cool things with the colors. Like you could multiply the position of each of them. Like if you wanted to change the tip, like the tips of each thing, you could change the color by just putting that into like this equation, right? So like the output of the Voronoi, you could put this into a color, multiply it by the color, and then the tips of the, and yeah, so I mean, that's pretty much it for the blob. That's looking really good. And now what I did to make it chase you. All right, so this is the code that makes it chase you. So in the fixed update, we're setting the position of the object. So the transform, this script will be attached to the black blob itself. And then it move towards will move from this position to this position. I have a method that a helper method that I made to change the y-axis of this, because my player's position is 0 on the y-axis. So if I put this object to 0, it will be halfway under the ground. So I want this object to be floating, so that's why I removed the y and I set it to 25 instead. And then this is the speed at which it moves towards that object. So like 0.5 is actually, it's kind of fast, but if it was any faster than this, it would be really hard to avoid it, especially since it's chasing you for the entire run until you get rid of it or whatever. It would be really annoying if it was any faster than that. But then I have this on collision code, which is basically if I collide with my stickman, it does damage to him. This just pushes my character back, and then this just does damage to my stickman. This code might not be relevant for you, but I didn't make this an enemy, so I have an enemy abstract class that I use for all of my other enemies so far. But because this enemy doesn't take damage, it's not using a nav mesh agent, it doesn't, like, the abstract class, basically when you damage the enemy, it has reusable code that makes like an explosion kind of thing happen around the enemy. I don't want that to happen for this black blob because he doesn't take damage unless you have the light card or some. I'm gonna make other ways of killing him too, but it's gonna be like very, very rare that you're able to just kill the black blob. So this is the code for that, and yeah, if you run it this is, you can see that he's just chasing my character around indefinitely. And if I go between rooms or whatever, he doesn't like die or disappear or anything like that. He's just there forever. So I hope you guys enjoyed the video. Make sure you leave a like and subscribe to the channel if you want to. And also, more importantly, join my Discord. I have a Discord channel now. It would be great if you guys could join, and you can, if you have any problems with your game, I'll likely just help you for free. So you can join my Discord. You can tell me your ideas for my game or for your game. Send me pictures of your game. I'd love to see them. And yeah, I hope you guys enjoyed the video, and I'll see you in the next one.